All right, so now I'm going to show you how to take the derivative of inverse secant. And this one is a little bit funnier than any of the other inverse trig functions, but the strategy we're going to use is still the same. So yeah, first, the strategy is we call this inverse secant function f of x. F of x equals inverse secant of x, right? And we don't know how to differentiate this, but if we take secant on both sides, right? So that means on the left-hand side we have secant of f of x. And then on the right-hand side, all we're left with is, well, the secant and the inverse secant cancel, leaving you with the x on the inside. Well, now you know how to differentiate everything, because you know what the derivative of secant is, and you know what the derivative of x is, and you know how to use chain rule, right? So let's go ahead and differentiate. Derivative of secant is just secant of that thing times tangent of that thing. Secant of f(x) times tangent of f(x). And then on the inside you have your inside function, which is f of x. So you have to multiply by its derivative. And that's the left-hand side done. On the right-hand side, the derivative of the derivative of x with respect to x is just 1. Okay, now we have to isolate this f prime, because f prime represents the derivative of inverse secant. So we just divide this massive thing on either side. So on the left-hand side, all you're left with is that f prime of x, which came from the chain rule. On the right-hand side, in the bottom, you have secant of f of x times tangent of f of x. All right, and on top you have a 1. Really easy. Because now you have to remember is we set f of x to be inverse secant. So we can go ahead and plug in inverse secant wherever there's an f of x. Now that leaves us with some pretty easy work in this first factor, because secant of inverse secant is just whatever's on the inside. So that's x. But we still have this tangent to deal with. So we have tangent of f of x, which is equal to tangent of inverse secant. And on top, we still have this 1. So very nice how this and that cancel. So you're just left with this remaining x. However, this guy is not so nice. We want to rewrite tangent in terms of secant. So how do we do that? Well, we know there's one connection between tangent and secant, and that's that tangent squared plus 1 equals secant squared, right? But here, you just have the tangent by itself. So we have to isolate tangent. Tangent squared equals, well, subtract 1 on both sides, you get tangent squared equals secant squared minus 1. And then taking the square root, now you have tangent by itself equals the square root of secant squared minus 1. So you just take this and then replace it with the square root of secant squared minus 1. So the square root of secant squared. On the inside, you still have this inverse secant. And then you still have this not minus 1. Hopefully you can understand where this came from, right? This is just the Pythagorean identity, and then all we did was just isolate tangent. All right, anyways, what's in here is just x squared. And in case that's not obvious, remember that secant squared of, say, call it y maybe, is just secant of y squared. So if y was inverse secant, then we would have, right, that's exactly the case we have here. So secant squared of inverse secant of x is just secant of inverse secant, and then the whole thing gets squared, like this. So that's how you should think about this, because this square, they're both just saying the same thing. You're just squaring the secant function that's on the very outside. Anyways, this secant and this inverse cancel out. So you're just left with this x and the square. So you just have an x squared. So what I'm saying is this thing is just equal to x squared. So if we go ahead and replace it, then in the bottom we have x times the square root of that thing, which is just x squared, minus 1, right? And like that. So that right there is the derivative of inverse secant. And I'm not sure if teachers want you to memorize this or you have the spare time to just find it yourself, but this I would memorize. When it comes to the inverse hyperbolic trig functions, then maybe not those, because those are, they're rare to find. But yeah, this I would still memorize, because it just takes a long time to find again, right? Like, just look at that. Okay, so we know that the derivative of inverse secant is 1 over x times the square root of x squared minus 1. So what about the derivative of inverse cosecant? Well, we're going to do the same thing as we did in the previous two videos, right? We're just going to use the inverse cofunction identity, which I already explained in the video where I differentiated arcsine, the inverse sine. And that identity is as follows. Say you have an inverse trig function. If you add it with the inverse cofunction, so in secant's case, that would be inverse cosecant, then that would be equal to pi over 2. So we can use this to differentiate inverse cosecant. So let's do that. Take the derivative of cosecant to the negative 1 of x. So this is inverse cosecant. And the reason why I say we can do that using this is because we already know the derivative of inverse secant, right? So what we can do is isolate this inverse cosecant and then write it in terms of this inverse secant, which we already know how to differentiate. So on the left-hand side, we're left with inverse cosecant. But on both sides, what we can do is subtract off inverse secant. So on the right-hand side, what you have is, you still have this pi over 2, but you subtracted inverse secant on both sides. So now you have pi over 2 minus inverse secant, like that. So we can go ahead and replace this with that, because we may not know how to differentiate this, but we know how to differentiate that. So this is equal to the derivative of pi over 2 minus inverse secant of x, like that. Now you can go ahead and straight up differentiate, because the derivative of pi over 2 is just 0. It's a constant. And then you would differentiate the second term. There's this negative sign, which I'll keep, and then you have the derivative of inverse secant, which is that thing. So I'm going to just copy that down. It's 1 over x times the square root of x squared minus 1. Right, there's a 1 on top. There you go. That is the derivative of inverse cosecant. And once again, just like all of the inverse trig functions, the derivative of the coversion is just the negative, right? So there you go. Pretty simple.